think is our 107th meeting, and I had quite a big set of notes last week just because we had behavioral model and the dash call, and I'm hoping it was okay with you guys that I just combined the notes on the email that went out. I'm not sure if you saw it, but can you guys see my screen okay?
Yep.
Yeah, okay, cool. So here's what, and I can separate these if we need to, but of course, last week we got a preview of those two HLDs, and we were going to cover Flow Resim later, and then I saw Marian's and someone else's PRs in the Open Compute repo, so I just threw that in there, and we worked on 8. We closed 8 last week, so that was the summary basically, and then these were the ones we had gotten done. And then the longer notes here were actually what we talked about. AI is getting pretty good. And then I put the behavioral model notes down here as well. So if anyone's not getting these, let me know and I can add you to the group. So, and then of course the recordings here. So, this week, I was wondering, I saw quite a few PRs in the queue, and I was wondering this week if maybe were there ones you guys wanted to talk about first before I start going through things? The newer ones I can see are here by Kamil and some HA stuff by Riff, and then I thought I saw a PR from Marian, but
I have an older PR that I just
okay.
brought it up to date with the refactor.
Was it 515 or something?
Yeah,
No.
yeah.
Yeah, this one. Yeah.
So it didn't really change much, except now it is mergeable because it resolved all the conflicts and all that.
Oh, awesome. So it's ready for a merge?
Yeah, Riff,
Okay.
maybe you could take a look at that.
Yeah. So when I talked to Gohan last, he wanted to make sure there was a reviewer. So if Ashutosh and Riff, if you guys could do that, then we can do a merge. Yep. Is that cool?
Yeah, I'll do that. Yep.
Yeah, sure. I will do.
Because PLSG, there are some new updates, so I will make sure like the actual line with the new design. Yep. Thanks.
Okay, so just put and Ashutosh, were you okay with that too?
Yeah. I will review it.
Okay. Okay, thank you. So that's the only one for you, Marian, that you wanted to talk about?
Yeah, there is another one I'm working on, the route groups, but I just need to enhance all the tests because there is now a new object. So I need to go over the tests. It's not ready yet.
Yeah, that's fine. Thank you. Thank you. Did you guys have any questions about those before we move on? Okay, I kind of want to look at this one from Kamil. I don't see Kamil on the call. I'm calling create function.
I can explain.
Oh, sure.
Yeah, so basically, currently in the Dashlib side, what we are doing is that whichever attribute we set, then in the dash side we will actually pack it, send to the BMV2. However, in the BMV2, different action may expect different list of the parameters or attributes. So when people are calling the API, it doesn't really know, or there are a lot of APIs actually has a default value because it can be like omitted. Then if anything is missing, the BMV2 API would fail. It's like, missing parameters. So what this change is doing is that if there is any parameters that has a default value, it is like skippable when calling APIs. The dash side will actually add the default value in, so BMV2 can just run without like providing the full list of the attribute. Otherwise, every time we add a new attribute, it will actually break whoever calling the API.
Yep, that makes sense. So
Yeah,
wait
I'm
for-
familiar with this problem. I can approve, I guess.
I'm sorry, what did you say,
So-
Marian? You're familiar?
Yeah, I'm familiar with that problem. I had to fix tests because of this issue, so I will approve the pull request.
Awesome. Do you want me to, I'll add you as a reviewer then?
Mm-hmm.
Okay. Awesome, thank you. And this one, it looks like you added Riff, add bulk sync support.
Yep. So if we have some time, we can go through them later in the meeting. So
Okay,
bulk sync
all right.
and flow reconcile.
Okay,
Yep.
got it. And then update P4 for the latest metering. Okay, so it sounds like a add-on to what we were doing last week.
Yeah, so this is the metering HLD
Yeah.
implementation. Yeah, so it's updated. The test is not updated yet, so it is currently failing, but I'll get some fixed soon.
Okay, great. So before we go into this one here, 548, did anyone else have one they wanted to cover? Okay, sounds good. Go ahead, Riff. Do you want to present or do you want me to?
Yeah, I can present.
You want to? Okay.
We actually have three topics.
Yep.
One is the flow resimulation.
Yep.
The other one is the updates on the SWSS API. Okay.
Yep.
So share the screen. This one. All right. Can anyone see my screen now?
Yeah, I can anyway.
Okay, sounds perfect. So let's first start with the flow resimulation HLD. Okay, and this is basically the flow resimulation. We sent the flow resimulation HLD before, and this one will be like much simpler, so we can actually have a more flexibility on how to optimize it. So there is no big constraint or any of the implementation constraint. So that's one thing. Another thing is that we have removed the learning-based the flow resimulation. So all the flow resimulation will be triggered from the SDN controller, so explicitly, or the host. So here as we can see, I have removed the preview from the title, so it's basically the final version. I'm not expecting any changes anymore. So this one is basically just waiting for like final sign off. Yep.
Awesome.
Okay. Yep. So basically internally, we have went through the docs like twice. There's no more questions. So I would consider like this is the final version. Okay. So the flow resimulation. So for this one, let's still start from the the background. Basically, the background is that whenever the network policy is changed, the SDN policy is changed, we will need to like update the existing flows, depending on the cases, to actually pick up the latest policy. There are two major use cases at the moment. The first one is that we will have like the full flow resimulation. So this one is usually used when echo is updated. So all the flows needs to be updated to pick up the latest policy. The second one is a policy-based flow resimulation. So this one is usually for example, CAPM mapping. So it can be used when the policy doesn't have any overlap. For example, if route, for example, when route entry is updated, then we one or there is a new route gets added or whatever, the flow then was hit once one route entry could now hit another route entry. In this case, policy-based flow resimulation may not be able to cover like the expected the flows because there could be some flows are missing. So in this case, full flow resimulation will be preferred. The policy-based flow resimulation is targeted to the policies which doesn't have any overlap. for example, CAP mapping. Like none of the CAP mapping will overlap with each other, which is currently only the CAP mapping will have the flow resimulation attribute added. Okay. So the one thing to emphasize is that for both cases, for both flow simulation or policy-based flow simulation, the trigger is always explicit from the SDN controller. So, or from the host, like we need to call the API to actually trigger the flow simulation. There is no implicit one. For example, CAP mapping updates, it will not implicitly trigger the flow simulation. Although we know in a lot of cases flow simulation needs to happen, but the trigger needs to be explicit. All right, then after the use case, let's see the high level packet flow. This is mostly conceptually how the flow simulation works. It doesn't really imply the real implementation, but ideally, or sorry, not ideally, like conceptually, it should follow like these 3 steps. The first one is the trigger. Something happens. For example, policy gets updated, so we actually call the API to trigger the flow simulation. Then so this is the trigger. The second one is that then certain things need to happen to mark the flows as resimulated. No matter it is like the epoch or some other mechanisms, flow table work. So there needs to be something to mark those flow as needs to be resimulated. Then it goes to step 3. The step 3 is a flow resimulation that actually when the next packet comes, it will go through the slow path, pick up the latest policy. So that's basically how the resimulation actually works. So the 3 stages. So we find the flow, and the flow needs to be simulated. Then we go through the slow path, gets the latest action, and then updates the flow table like this. All right, and goes into the resource modeling. So basically, flow resimulation is on the ENI, or this is the full flow resimulation, or on each CAPM mappings like policies. Okay, and the scaling requirement. So basically, because flow resimulation goes through this, basically goes through a slow path, then it means that the CPS we are talking about is actually CPS plus the flow resimulation. So that is 3 million. And then the max number of flows to update, we actually have a configuration on the ENI level to specify like the max number. So then there is another thing is that I see Ashutosh raise a hand. Hey Ashutosh, what's up?
Okay, so I have a question. Let's say, so I understand the ENI based case, but let's say the other case about the CAPA mapping table, right?
Right.
And so normally if the flow is established, the packet comes in, if it fits in the flow table, we will not look up the CAPA table, right? So even if you mark a certain entry in the CAPA table to say that this entry needs to be resimulated, but typically we will not even look up the CAPA table. Right. So I'm just wondering how would we do the flow? How would we mark the flow?
So which is the reason like this is a flow marking. This is not like a policy marking. So I'll take a very naive approach. This is probably not going to be the ideal one, but a very naive approach. Say we update the CMP mapping, and then we say, okay, this map, all the flows associated with this mapping needs to be updated. What we could do is that we could have or this is also what we probably are going to do in a behavior model. Is that we could have the the data plan app doing a flow table work, find all the flows that are associated with this mapping with certain tracking keys or whatever, and we pick up those things and change the flow state to resimulation needed. So that's basically a very naive way to implement it. but it is doable. There could be other optimizations. Yes, depends on the
if you walk through the table, you can definitely do it. It's just that you have to walk. I mean, if the naive implementation, a brute force implementation will be to walk through the whole table and try to figure out which of the entries will get impacted based on the destination IP, most likely. Okay. But there are optimizations possible, you're saying. And that's implementation dependent.
Yes. So there are many ways to optimize this, but the very naive way is to walk through.
Okay, got it. Thank you.
So there is one thing that we're still getting the data, which is maximum latency to complete the flow, like flow resimulation call. So this is also basically the if this one time if we use like 1 second to divide by this number, this basically maps to how many calls we are actually expecting for within a second. So we'll get this number later, but this one is to be done at this moment. Okay, so we'll probably
do you have some idea of the number, like is it like thousands, hundred? I mean, I know the not exact number, but like at least some idea about what this number will be.
So the for the policy based, so this one I will probably skip it for now, just in case. But for flow resimulation, very naive way to implement the flow simulation, because it basically marks the entire ENI as invalid, right? Yeah, so we can actually have a SONiC versions or epoch on the entire ENI. So this one should be able to complete it really, really fast.
Okay. Because that's not walking through the table. Okay.
Right. But we'll come back with the number later, and also this one is for completing the API call is basically it's basically part of the flow marking. It could be the entire flow marking or part of a flow marking phase, and the flow resimulation, to complete the flow resimulation, that needs to go through CPS, but it will take as much time as it needed, because there could be like some flows they're just not that doesn't have like too much volume, and you have to wait for the next keep alive, and it could be like half a minute later, so or minutes later. So it really depends on the traffic. Okay, so this one is just complete a call. All right, and then reliability. So this one definitely needs the HPA support whenever the flow is simulated. Needs to be replicated to the standby side. There is another thing is that please. Okay, then I will continue. There is another thing is that in a HA switchover failover. So basically, if the flow simulation actually happens on one side, and then we trigger the failover, then the policy will go to the other side. In that case, a flow reconcile will actually be called on the failover. So basically, what happens is that when all the latest policy gets updated on the standby, and SDN controller makes sure like it is updated, for example, unplanned failover, then SDN controller will issue a flow reconcile operation that will actually resume the flow resimulation behavior, as well as doing a full flow resimulation, making sure like everything pick up the latest policy. So that is basically how the flow resimulation continuation work, which is something in the current HA, HLD, we have an open question over there, and this is basically the solution. And for this one, for flow reconcile, we'll go to the flow reconcile later very soon. All right. So the impact, because the flow simulation impacts the CPS path, so we actually just mentioned here. Then we have a rate limiting on the ENI level, so we'll go through the ENI level very soon. We'll go through a rate limiting attribute very soon in the detailed data. The final thing is a flow resimulation scope. What does the resimulation scope mean is that in the current Azure, as everyone knows, like we are actually using the VIP. There are a lot of people already talking about how VIP works, so I'll just skip this one. But the VIP, in the VIP, we have multiple layers. Each layer will actually have a flow catch, and that catches part of the actions. So basically, to making sure we have the parity to what VIP is currently supports, we actually, this is why like a resimulation scope is needed to provide like a partial flow resimulation. So we'll go through the API very soon. Okay, the final one is, sorry, not the final one, but there are two more. There could be routing type change, depends on the, probably some incorrect configuration happens. In those cases, say previously it was doing a private link, and now it is doing the VNet incap, or even just direct or whatever. So there could be like different routing type change. In this case, the behavior could be like undetermined. So it could end up with unexpected packet, but practically we are not actually expecting any of these like routing type change actually happening in the system. So right now it is expected and acceptable. The final one is fast pass. So this fast pass is a LB, like the load balancer fast pass ICMP flow redirection. So when the flow gets redirected, then this flow will be removed from the flow resimulation. So even though we explicitly cause flow resimulation, this flow should not be resimulated and pick up the latest policy. I'll take one example is under the PRs, the private link case. So when private link happens, the flow will actually point to the private link service. Sorry, when the flow is established for the private link, it will point to the private link service, and then the fast pass kicks in and redirects flow to the backend VM. In this case, if flow resimulation resimulates the flow, then what happens is that it will pick up latest policy, points to the private link service again, and then may break the connection, depends on the cases. So when fast pass kicks in, the flow resimulation should be disabled for this specific flow. All right, then that's basically all the requirements. Let's see if there is any questions. If not, we'll go into the detailed design. Okay, the detailed design is actually fairly straightforward. So yeah, as you can see, just a little bit and with the counter. So for the full flow resimulation, this will happening on the inline level. Basically, just one single attribute sys and full flow resimulation requested. There is no more APIs to get the versions or get anything. Basically, just like a request attribute, and it will set to true or false. And then if it sets to true, we will consider like the request is sent. And once the request is received, doesn't mean it has to be complete the flow simulation. Basically, is then okay, if the request is processed, then the value can be reset to false. Like this reset will be more like it's not like a notification, because it basically is a fair forget. But if anyone needs to get the requested attribute using the SAI API, it will return false. So before it is completed, it will return true. So that's basically it. Policy-based will be on the CAPM mapping table, and is follows exactly the same thing. Just the flow resimulation requested attribute will be added on the CAPM mapping table. That's basically it. Rate limiting. Rate limiting is on the inline level. Then I will have the maximum resimulated flow per second instead of having more complicated settings. It's just like the maximum resimulated flow per second. That's pretty much it. Default is 0, which means that no limit will be enforced. So basically, whichever way like the current or default implementation is, we just use the default implementation. So the last one besides the counter is the resimulation scope. So what does it do is that because we need to have the feature parity for the layer catch flow, which is like for different action. So for the routing action, in current dash design, we have a concept of the routing actions in each routing type. So that means that we can actually really leverage that concept. So for each routing action, we will actually have a bit like this. And then on the for example, on the here, on each policy, when we publish the routing type, we will have the this flag put over there. It's called disabled in flow resimulation flag. What it does is that it is a bit mask that has all these actions listed over there. So same thing to the CAPM mapping. And for example, in the prevalent case, and if we like to disable the flow resimulation, then we can actually have the 46 and static incap disabled. If there are some other cases where we only like to have, for example, the inner ones, like the overlay transformation, like put it over there, but the outer incap, we like it to change because there are some, for example, line migrations or whatever. So we like the outer incap to change. Then we'll leave the inner ones disabled, but outer ones like leave it not set. So the outer ones will still keep going. So that's basically all the APIs for controlling the flow resimulation. And the last one is a counter. The counter is that basically we will have the basic counters for all the flows. It's same thing for the HA, same thing for other cases. And the only difference for the flow resimulation is that we will add 2 dedicated counters for resimulation. So what does it? Why we have the dedicated counters is because there are other cases could also update the flow. For example, like the fast pass, the flow redirection. So this one. So because of this, the flow resimulation will have its own dedicated counters because it will both of the flow resimulation and the load balancer fast pass will show up in the flow updated counter. So we actually don't know which one is which one. That's why the dedicated counter will be put over there. Okay, that's basically the whole HLD. So is there any questions?
No questions from me. That's just a ton of work. Thank you, Riff. Anyone else?
Okay. If not, we'll continue. And if there is any questions, feel free to reach me offline. I will be happy to answer any questions. All right.
Cool. Thank you. Thank you.
Yeah. Then
I did. Oh, go ahead.
Oh, yeah. Sorry, Christina, please. If now we can continue. We have 2 more, but this one is more like add-on on the top of the current HA session APIs. So it should not take too much time, hopefully. All right. So then the HA session API. So the first one is a Flow Reconcile. What does a Flow Reconcile do is that when we think internally on the HA designs, and there is one thing in unplanned failover is that, okay, what if the flow resimulation actually happens? How can we resume? How can we make sure like the SDM policy doesn't go back in time? So the existing flows will not be pick up the old policy again, because the active side could be running as a new policy, while the standby side is not programming yet, is running the old policy. So in this case, the only one that knows the flow, which policy is up to date, is actually the SDM controller, which is why the Flow Reconcile is introduced to explicitly address this problem. And this problem is also left open in the current like HA design, because we in that cases, and there is no way to tell, like if it go back in time, yeah, it will go back in time. So we like to avoid this case, and this is why the flow reconcile is put in here. Okay, so basically it's the background. So it avoids the SDN policy goes backwards. How it works is that whenever the HS scope like DPU or ENI enters a new row, that makes the flow decision, but it was previously not in the row that makes the flow decision. So what happens is that two things will happen. It will stop the flow resimulation, even though upon request. So we'll say, okay, this policy, this mapping, because all the policy updates is still happening in parallel. So what happens is that even though the policy updated, we'll say, oh, please don't do any flow resimulation. Then will probably make the policy going backwards, because there is no in the unplanned events, for example, there is no like concrete indication that all the policies are already programmed. All right, it fails over, it fails over. It goes to standalone, it won't go to standalone. So in those cases, this is the first thing, is that we will stop the flow simulation. The second thing is that there will be a notification. The implementation is to send a notification to say, hey, please, whenever you are ready, please issue a flow reconcile, and then everything will be resumed afterwards. So how it looks like is, okay. How it looks like is that, yeah, probably it's better to just build file. Although this one shows a div, so we actually can see. But how? Sorry. Oh, there you go. So on the HS set, there are two attributes will be added. The first one is that flow reconcile requested, which means the SDN controller will actually explicitly call this flip this attribute to initiate the flow reconcile. The second one is a flow reconcile needed attribute. That means that it is read only, so nobody will actually set it. But if it is true, then it means the flow reconcile is actually currently needed. It's not complete or requested yet. So the things for the notification is actually on the scope, and because it goes with flow that goes into the row. Changes the row, like HA row. So it could be on the DPU level or could be on the ENI level, but whichever level the row is changed, the HA scope will have the flow reconcile needed event being sent. So that's basically it. So that means that the HA scope now would have two events, or one is the state changed, which means all the HA row and flow version is changed, or the flow reconcile is needed. That means that although we enter the row, but now everything is stopped, so we actually need to reconcile, need to wait for explicit signal to reconcile the flow, then resume the flow resimulation, and also as well as triggering full flow resimulation. So that's basically how the flow reconcile works. Okay, so that's pretty much the flow reconcile APIs. So I'm already added Mukesh and Marian as a review, and if anyone else like to review this design, feel free to leave the comments. And if there are any questions, feel free to let me know. All right. Then the next one is a BoxSync API. So this one, the initial HA session API will actually covers the HA state machine as well as the inline flow sync. So this one is an add-on to add the BoxSync support. So basically, how the BoxSync works from side point of view. So the background is that on the source side, a Flow API would be called to actually create a BoxSync session. The BoxSync session, because it is the BoxSync session basically would actually trigger the source side the DPU to send out the flow record directly to the destination side. When the session is done, when the box session is done, then the event would be sent out. Will actually notify the HA control plan to actually close the session. But basically, this is how the boxing actually works. So it basically is a direct flow record push from the source side to the destination side. And later we will add the SWSS as man in the middle. So for that one, we will be able to support like a virtual DPU. We'll have like multiple DPUs, like to form a bigger DPU. So in case of like flow, like a flow redistribute needs to happen when you actually sync to the standby side, depends on the hash. But without the SWSS, like what happens is that it will just DPU directly syncs to the other side of the DPU. So there is no control plan gets involved in this case. Okay, so and then because of this, the API is actually fairly straightforward. Is that on the HA set, we will have the control plan data channel port being set here. So this one is to avoid like, because we actually have a lot of services that's running on the DPU, and also like some of the like for example all the SONiC services. So a lot of them actually open support. So in order to making sure like people like different services don't step on each other's toe, we will actually have a port like explicitly specified here. So we will actually be safe. Yeah, but that is basically the gRPC server port. Okay, then the second one is beside of this, how to trigger them. We'll cover that in the Flow API. So we will skip it here. So you'll come back later, and this is pretty much the only configuration we would add. And beside of this, there will be a few more like counters being added here. For example, like the how many connects being attempted, how many connects received, succeeded, failed. Failed means that if there any reason that, for example, like timeout, it was connected but suddenly just like disconnect or whatever, or it being rejected. It is received but being rejected because the search is not okay or something happened. And then yeah, another one is just explicitly like timeout. And then for the bulk sync, there are two counters being added here. Sorry, two categories of counters. The first one is how many messages, how the message is doing. So message received, message sent, and message sent, but it was failed. Or how many flows are received. So that means that besides the message, there is another one for the flow. But when we say when we send the flow, then it basically means that it already like the failed is already covered by the message, so the flow doesn't have the failed case. But why we have a flow is that because each message would have a many flows, could have a many flow record being batched sent from one single bulk sync message. So that means that we need a two counter to see how the things work. Okay, so that's basically like all the things for bulk sync. And now, is there any questions so far? And if not, I'll give it back to Christina.
Okay, thank you.
Right.
Were there any questions, guys? Kind of a big topic to take in, yeah. So thank you, Riff.
Yep.
Yeah, we can always recover pieces if we have questions. Yeah, thank you so much. And I just had two other things that I noticed this week. I'll share my screen. So here, I noticed that we had one kind of go by, add VXLan tunnel to avoid build break in SWSS that just kind of got in, got coded, got done. So 552 here, and merged.
Yep.
So we have
Yep.
that
Thanks,
one.
Marian.
Yeah, got that one done. And then also, I noticed fixed SAI Challenger build break also got done. So if you guys haven't seen these or don't follow the repo, we got these two done this week.
Yep, use some external dependency change. So
Yeah,
it was
yeah.
working and suddenly
Yeah.
that doesn't work anymore.
Yeah, I appreciate it. I just kind of cruise through a couple of times a week and check on the new ones and things like that. Anyway, thank you for your time and attention today. That's all I have. Do you guys have anything you want to talk about? Okay, I'm kind of missing Andy with this 5-second rule thing or 7-second rule, but I'll stop the recording and give you back some time, 15 minutes. And have a good rest of the